Hello again. We are finishing our discussion of systems of linear equations, and we're branching out and talking about linear inequalities instead, and what happens when you've got more than one inequality graphed on the same xy plane. So let's get started. What is a system of inequalities? Well, instead of lines intersecting at a point, I actually have areas, because remember, inequalities are represented by areas, and they intersect to create an area. So the red area that I shaded first intersects with the blue area that I shaded second to create that purple area over there on the top right. Okay, so that would be considered the solution area to that system of inequalities. So every point in that purple area is going to be a solution to both inequalities. If it's just in the red, it's not a solution. If it's just in the blue, it's not a solution. It has to be in the overlap, that purple area. So in the graph shown here, the red area is y is less than or equal to 2x minus 1, and the blue area is y is greater than or equal to negative x plus 4. So the intersection is the purple part. So any point in the purple is a solution. So if I plug in any x and y from that purple area into both inequalities, it would create two true statements. Because they're inequalities, there's multiple solutions to each one. So for example, 3, 2, x equals 3, y equals 2, that's in the purple area. So if I plug that into the first inequality, I get 2 is less than or equal to 2 times 3 minus 1. Well, that's true, because 2 is less than or equal to 5. And if I plug it into the second one, 2 is greater than or equal to negative 3 plus 4, and that's true because 2 is greater than or equal to 1. All right, and that would work for any point in the purple area. So here's an example. Y is greater than negative 2/3 x plus 2. X plus 4y is less than 4. So the first equation is in slope-intercept form. The y-intercept is 2, and the slope is negative 2/3. It's a greater than sign, so I'm going to draw a dotted line, and I'm going to shade above. Remember, you would find a test point on either side to determine whether you shade above or below. But I'm just kind of going through the steps based on your knowledge of linear inequalities that we've learned before. For boundary 2, it's in standard form, so I find the x-intercept, that's 4. I find the y-intercept, that's 1. It's also dotted because it is a less than, not less than or equal to. And I'm going to shade below. I'm going to assume I already found test points above and below, and the one below is the one that worked. So I've shaded both. And so you can see the purple area there. That's the part that has all the solutions to both inequalities. So here's a real world example of that. Let's say I have a kid's birthday party. It's held in a room that will fit at most 15 people. And there's got to be at least one adult for every 4 children. So how many children and adults can be in the room? A plus C is 15. So you'll notice I have the adults along the bottom, along the x-axis, and I have children along the y-axis. So I'm treating A like x, and I'm treating C like y. Okay. The second equation is that C has to be less than or equal to 4A. So for the boundary for the first one, that's in standard form. So the x-intercept is 15, the y-intercept is 15, and because it's less than or equal to, the boundary line is solid. And I'm going to pretend I found test points, and I'm going to shade below that line. For boundary 2, the y-intercept is 0 and the slope is 4. It's also a solid line because it's less than or equal to, not just less than. And I'm going to pretend I found test points, and I need to shade below. So any point in the purple is going to be a valid solution. It's a situation that can happen, but anything that's in red or just in blue or not in either one of them isn't going to work. So if I look at 2 adults and 10 children, that's just in the red area, so that can't happen. If I have 9 adults and 9 children, that can't happen either. But if I have 4 adults and 7 children, for example, that could happen because it is in the purple area, not just the red, not just the blue, and not the white area that has no business even being there. So that's how I'm going to find solutions to those real-world examples. If you have any questions about this, please let me know, and I will see you tomorrow.